All right. So just want to start out with some housekeeping here. I apologize for my disarray. So today's date is February 3rd. Let's just start out with some housekeeping agenda items. If you have not turned in or uploaded your Chapter 11 homework, go ahead and do that, and I will give you the 10 points as soon as I get on Canvas. So upload that, and everyone will get 10 points. Again, homework is practice, and just upload a picture. Okay, don't type or do anything. Just, I'll check it off for the 10 points. Easy 10 points, so please do that. Work on your quiz. Okay, we do have a test coming up. And the way my system works is that the quizzes are due the same day as the test, but it's all going to be through Canvas. So I believe it's February 15th. And that is when Test 1 will also be made available to Canvas. I'll talk more about that as we approach that date. Lab this Friday. Okay, so be honest. Okay. How many of you have done the lab virtually, or this is when I hope people would lie?
You talking about the one for this Friday?
Okay, if you haven't done it this Friday, you can do it with myself and Larissa.
That's Lab 1, right?
Lab 1, yes. Lab 1, we're going to start Lab 1. If you cannot make it, I know you have other commitments, athletic needs and stuff, please watch the video and make your lab report from there. Okay? So lab this Friday, and it's on intermolecular forces. Okay, so watch the demonstration video and do the lab with us. If you do not or cannot, or for whatever reason, we filmed the lab for you to do your lab report. All right, so hopefully we can get 8 people to show up for Friday's lab, and it's very low key. We're not going to make things difficult. And I'm personally going to help you through it so that you can be done in a good amount of time and get the most out of it. And I'll tell you when the lab report for this is due. Any other questions? Okay, so either with me or virtually through the filming, you make the lab report, and I'll give you the due date for that lab report later. Probably the lab report will be due sometime next week, that you'll have to upload it to Canvas. Any of you still doing that clutch prep? I got an email from them this morning. I did not open it, but make sure you do those clutch prep drills for those of you that paid the $30. I know, Joshua, you paid the $30. That will help you besides my lecture, and it's just an own online tutor. Okay, it will also help you for your future classes, because some of the material in this course will be for your board exams or whatever future exams you take. I also want to start looking at Chapter 12 homework, or start looking at Chapter 12 homework, okay, because we're kind of in the middle of Chapter 12, and I want you to start doing those homeworks. I do have videos of all the Chapter 12 problems. They're on Canvas. Also, the instruction manual is on Canvas for you to check your work, and I'll give you a due date for this. Probably, like the lab report, it will be due sometime next week. Okay, so just be aware of that, and of course, I'll give you the 10 points for doing this. Are we ready for some lecture? Okay, ready to learn? Okay, let's see what we can knock off here on Chapter 12. Before we begin, I just want to tell you, I've been talking to you about the hydrogen bond. That is one of the themes of Chapter 11. Okay, remember, hydrogen bond, OH, with an H from another molecule, NH, with an H from another molecule. We don't see this a lot in my biochemistry class. Though it's not my class, it's the class is a class. We see an F with an H. That's a hydrogen bond. It's an unusually strong intermolecular force. Okay, so water can hydrogen bond to another water molecule. These NHs can hydrogen bond to another molecule that has an H in it. So if you do not doubt how important this is, and if you miss this on the exam, I'm going to force you to read this book and write a book report on it. Okay, the hydrogen bond. Okay. You have to read it and write me a book report. And it is 400 pages? Yeah, 386 pages. And you'll read it and give me a book report if you missed this question on the exam. Okay. A whole book dedicated to the hydrogen bond. So you can see how important this intermolecular force is. All right, let's get back to our notes. Right, one question that will appear on the exam, on the multiple choice portion, is can these guys mix? Okay, are they miscible or immiscible? Okay. Miscible, mix, or immiscible cannot mix. Okay, here we're going to use, if you see this on the exam, here we're going to use like dissolves like. Okay, like dissolves like. So let's go through these here one by one. Here we have C6H6. Okay, that molecule is called benzene. You'll see this definitely in your organic chemistry classes. It's called benzene. Okay, so you may want to memorize that. C6H6 has the name benzene. Okay, it's a very special molecule in and of itself. And you see a carbon and a hydrogen. And what intermolecular forces do you think this will have? Okay, it's a very weak force, and every molecule has it. It's called dispersion. Okay, hydrocarbons will have dispersion. So that's benzene. And will it mix with water? Okay, good old H2O. Okay, what does water have as an intermolecular force? Is it polar? Polar. Does it have hydrogen bonding? Yes. Okay, so here it's polar. Okay, what is C6H6? Okay, don't say polar, it is nonpolar. Okay, so like dissolves like, this will not mix. Okay, this is like oil and water. They will not mix, they will partition and separate amongst themselves. Okay. How about this one, C6H6? We know that as benzene. CCl4 is called carbon tetrachloride. It's a covalent molecule, nonmetals. Carbon tetrachloride. Okay, is this polar or nonpolar? Okay, let me draw for you the Lewis structure. All right, this Cl is pulling that way. This Cl at the bottom is pulling down away. This Cl at the left is pulling to the left. This Cl at the right is pulling to the right. So this would be partial negative, partial negative, partial negative, partial negative. Do the dipole moments cancel each other out? Yes, right, Elena? Up cancels with down, left cancels with right. Is this polar or nonpolar? This is a nonpolar molecule because all the arrows, those vectors cancel with one another. Okay, so benzene is nonpolar, CCl4 is nonpolar. Yes, this will mix. Okay, nonpolar goes with nonpolar. Okay, that is like dissolves like. All right, our next one on this list here is H2O, and ETOH is how I'm going to call ethanol. See, I'm lazy. I just call ethanol ETOH. Okay, will they mix? Okay, what do we know about alcohols, like an ethanol? Okay, what is the functional group? Methanol, ethanol, propanol, butanol, pentanol. Okay, they are ROH. Okay, the alcohols. All right, what do we know about the alcohols? Are they polar? Okay, yes, right, they're polar. Can they hydrogen bond? Okay, the OH, yes. So can an ethanol, which is an alcohol, know your functional groups or use that for the exam, that sheet? Can an alcohol mix with water, which also is polar? The answer is yes. Okay, like dissolves like. All right, what about H2O, which is polar, and CCl4, which is nonpolar? No, very good. And then finally benzene, which we already established is nonpolar, with ethanol, which we have already established is polar. Will they mix? No. Okay, so like dissolves like. You'll see this in a lot of chemistry textbooks. Like dissolves like. Right, so there'll be something like this on the exam, multiple choice. Can these mix or can they not mix? Okay, so make sure you are good with this multiple choice portion of your February 15th exam. Right, next we're going to jump ship and talk about concentrations. Okay, concentrations. So, concentration does not always mean molarity. Concentration does not always mean molarity. Here I have 1 molar NaOH. You notice I labeled it, I dated it, I initialed it. Okay? So it does not always mean molarity. Okay. Anybody got blood work done? Or, I'm sure you have. You're a paramedic or you've worked with it. Or you've probably seen a lot of blood. So if you take sample to the lab and they analyze your blood and they're measuring potassium or chlorine or whatever protein, okay, they're going to use a concentration. Okay, is it too high? Is it too low? Are you right? Okay, all from your blood sample. What I'm trying to tell everyone, or you guys, is that it's not always going to be expressed in molarity. Concentration will not always be expressed in molarity. Here are some others, okay? Here we have what's called mass percent. Okay, mass of solute over mass of solution. Okay, also recognize that solution is solute plus solvent. Solution is solute plus solvent. So this is kind of like part over whole. It's kind of like a part over whole relationship. Okay, we also have what's called a mole fraction. Any fraction is part over whole. Okay, you have a pizza. I take 1 slice of pizza. I took 1 over 8. Okay, 8 slices of pizza. Part over whole is a fraction. Here we're not talking about pizza, but moles. Part mole over the whole thing, mole. That's called a mole fraction. Okay, and if we want a percentage, all we need to do is multiply by 100. Okay, this is good to know. Okay, let's skip down here to molarity. Moles of solute over liters of solution. Okay, and that is big M. And here we go. Okay, here's something that will give a lot of us some difficulty. This new type of concentration term that I'd like to teach for you today, and that's molality. Okay, it's little m. And molality, little m, is moles of solute over kilogram of solvent. Okay, we call this molal. We want to contrast that with molarity, which is what we talked about a little bit on Monday. Moles of solute over liters of solution. Okay, we call this molar. As an example, hey Courtney, get me this 1 molar solution of NaOH. Hey Josh, here you go, 1 molar NaOH. Big M. Big M. Right, so this is something we want to discriminate ourselves. Again, this is concentration. Okay, how do we express as something as concentrated? How do we express something as dilute? We attach a number to it. Okay? And these are the units of concentration. Okay, so let's go over some, what I consider a little bit difficult, even for me, problems. And I think you'll have this maybe in your quiz. Perhaps on your exam you'll have to check the study guide. But we're going to convert now between big M and little m. Okay, molar and molal. Molar, molal, molal, molar. Are you guys ready? Okay, so I think this will take the bulk of our class doing some of these types of problems. All right, our first practice problem together, convert 0.396 molal of glucose to molarity. Okay, so we're converting small m to big M, and all these types of problems you'll be given a density. Okay, so here the density is 1.16 grams per milliliters. Converting molal to molar. Okay, let's first identify the solute and the solvent. Okay, the solute here is glucose. Okay, glucose is C6H12O6. Okay, I'll give you this on the exam. You do not need to know the formula for glucose. Okay, what do you think the solvent will be? Okay, it's not explicit here, but we can say water. Okay, we can say water, and in fact, if you say water on the exam, it's going to be water, unless someone tells you something else, unless the problem tells you something else. The solvent is going to be water. Okay, so we got our solute and solvent. Okay, let me again remind us what little m is. Molal is moles of solute over kilogram of solvent. And we need to go from that to big M. Which is moles of solute, liter of solution. All right, 0.396 molal is nothing more than 0.396 moles of glucose over kilogram of solvent, okay, over kilogram of water. Okay, our solvent is water. Best assumption, okay, go with it. Water is our solvent. That is what 0.396 little m means. Okay, that is its operational definition. Right, 1 kilogram of water, which is our solvent, that is the same, is it not, as 1,000 grams of water? 1 kilogram is 1,000 grams, is it not so? Okay, so I'm going to say 1 kilogram of solvent, which is water, is the same or is equal to 1,000 grams of water. All right, the next thing I'm going to do is I'm going to convert 0.396 moles of glucose to grams of glucose. So we're going to convert 0.396 moles of glucose, which is our solute, to grams of glucose. We have 0.396 moles of glucose, which is C6H12O6. Again, I'll give you that formula on the test. Times for every 1 mole of glucose. The periodic table, I got about 180.04 grams of glucose. So the moles and moles of glucose cancel. And on my calculator, I'm getting 7.130 grams of glucose, which is the same thing as 0.396 moles of glucose. All right, we're not done yet. All right, so remember, solute plus solvent equals solution. Okay, well, I got my solute here, which is 7.130 grams. Okay, what is my solvent? It's right here, right? Is it not so? 1,000 grams. Plus 1,000 grams. That will equal to my grams of solution. and that is 1,701.3 grams of solution. All right, now I have the grams of solution. I can take it and put that through my density to get mils of solution, to get milliliters of solution. So let me switch this over here. So we have 1,071.3 grams of solution times, what is the density of this thing? The density of this thing is 1.16 grams per mil. Yes?
It's 7.13 plus 1,000, right?
Where are we here?
Yeah, because you got 1,071.3.
Oh, sorry. Thank you. Thank you. My bad. Appreciate that. Thank you, Sally. So that 1,007.13 grams, right? Yeah. Thank you. So I cannot add, basically, is what you're saying, which is right. Okay, so 1,007.13 grams. I'll give myself partial credit here. So 1,007.13 grams of solution. Okay, the density of this thing is 1.16 grams per mil. So I'm going to say 1.16 grams per mil. Okay, that's the density that was given to us. I'm going to go ahead and convert this to liters. 1,000 milliliters is 1 liter. Okay, the grams of solution cancel with the grams, the mils, and the mils cancel. So 1,007.13.
She's got to use the calculator now.
Huh?
She's got to use the calculator now.
0.13 divided by 1.16. I don't trust myself now. And then let's divide that by 1,000. 0.868 liters of solution. 0.868 liters of solution. All right, finally, I think we have what we need to solve this problem. A little bit messy, but what can you do? Moles of solute. Moles of solute is, what is our moles of solute? What is our moles of solute? 0.396, very good. Of glucose. What is our liters of solution? Our liters of solution. Everyone get that as our liters of solution, 0.868. And let's do that on our calculator and get our final answer. I will tell you, I'll be the first to admit that these are not the easiest problems, so 0.456 big M. 0.456 big M. So here they got 3 significant digits. Here they got 3 significant digits. So I'll go with 3 significant digits. 0.456 big M as our final answer. It's tricky. Okay, I'll tell you that. Okay. And let's do a couple of more here. See how far we can get. page 4 of our notes here. So I'll scan these and email them out at the end of class, so in case if you didn't get it or anything. So, all right, more practice here. Calculate the molality. Okay, molality, remember, is small m, moles of solute over kilogram of solvent. Moles of solute over kilogram of solvent. Molality of a 5.86 molar solution. Molar is moles of solute, liters of solution. And we got here, in all these problems, you're going to need a density, okay? You'll need a density. Let's first identify our solute and solvent in this situation. Okay, you know, the solvent is going to be water, unless otherwise you're told. So let's just go with solvent being water. And our solute is going to be ethanol. Okay, I'll just call it ETOH, the alcohol known as ethanol. Okay, 5.86 big M. Okay, big M. That means 5.86 moles of solute, which is ethanol, formula CH3CH2OH, over a liter of solution. That's the operational definition of molar, big M. So this 1 liter of solution, okay, isn't it also the same thing as 1,000 milliliters of solution? Okay, isn't it? Okay, it is. Same thing. 1 liter is 1,000 milliliters. 1 kilogram is 1,000 grams. So establishing this, we'll say that 1,000 milliliters of solution times the density is 0.927 grams per milliliter. 1,000 times 0.927 is 927 grams of solution. Okay, we can also say this. Okay, we can say that the grams of solute plus grams of solvent equals to grams of solution, right? Solute plus solvent equals solution. Grams of solution. Excuse me. So we got our grams of solution here. Can get the grams of solute. How will we get that? We'll get that by converting this 5.86 moles to grams. So let's convert 5.86 moles of ethanol to grams. Uh-oh, there we go. Moles of ethanol. Okay, this is our solute. 2 grams. So let's do that really quickly. 5.86 moles of ethanol times 1 mole of ethanol has how many grams? Looking at the periodic table, I'm getting 46.06 grams of ethanol. Okay, that's from the periodic table. And then moles of ethanol cancels out with the moles of ethanol. So 5.86 times 46.06. Sally's got me has got me a double check in my math here, which is good. Okay, that's a mark of a good student. 5.86 times 46.06 269.9, let's call it 270 grams of ethanol. We're converting the moles of solute to grams. All right, now we got our grams of solute. Okay, so let's go ahead and substitute numbers in. I think I'll use pink. No, pink doesn't show up well. I'll use this color. Grams of solute is 270.0 grams plus grams of solvent equals grams of solution, 927 grams of solution. So our grams of solvent is going to equal to 927 grams minus 270 grams. Okay, let's do that on our calculator. 927 minus 270. I'm getting 657 grams of solvent. Okay, 657 grams of solvent, which is water. All right, I think we have everything that we need to solve for molality small m. Okay, so our moles of solute is, what is our moles of solute? Moles of solute, 5.86 moles of solute, everyone see that? Divided by, what is our kilogram of solvent? It's our kilogram of solvent. Well, we've got grams of solvent. Let's go ahead and convert that to kilograms. So 657 grams of solvent. Okay, what's the conversion? It's 1,000 grams is 1 kilogram. Okay, so you may want to memorize that conversion factor. The grams and grams cancel. 0.657 kilograms of solvent, which is water. Okay, let's put that here. 5.86 divided by 0.657. Let's do it to three significant figures. 8.92 small m. Small m. Okay. 8.92 molal. 8.92 molal. And that is that concentration in the bottle. Okay. Again, tricky. All right. So, tricky and tricky. That's all I gotta say. All right, let's do a couple more here, and then I think we can wind up today's lecture. All right, calculate the molality. Okay, here we have small m molality. Again, molality is moles of solute, kilogram of solvent. A 44.6% by mass aqueous solution of sodium chloride NaCl. Sodium chloride NaCl. So 44.6% by mass. So what is the definition of 44.6% by mass? Okay, this is the definition. 44.6% by mass means that there's 44.6 grams of NaCl in 100 grams of solution. Remember, part over whole. Okay, I'm sort of deconvoluting the percentage. 44.6% is just 44.6 divided by 100. That is what this mass percent means. All right, let's do our solute solvent identification. Our solute here is NaCl. Okay, here aqueous, again, you can always assume it's water unless explicitly told otherwise. Solvent is water. All right, 100 grams of solution. That's what we have here. And out of that 100 grams, 44.6 grams is sodium chloride. So how much of that is water? Okay, so grams of solution, grams of solute, plus grams of solvent. We have 100 grams of solution. That is the definition of mass percent. 100 grams of solution. The grams of solute, that is the definition of a mass percent, 44.6. I'll call it NaCl. And then all we need to do here is solve for grams of solvent, which is actually water. So 100 minus 44.6, was that 54? Should do this in my head. 55.4 grams of solvent, grams of H2O solvent. Okay, let's go ahead and convert that to kilograms. Why am I saying convert it to kilograms? Okay, I'm saying convert it to kilograms because what is molality? Molality is moles of solute over kilogram of solvent. So converting that to kilograms, we'll move the decimal place 3 to the left. Okay, to get it to kilograms, 1, 2, 3, and that is 0.0554 kilograms of our solvent, which is water. Okay, all right, we're almost done here. So solute, kilogram of solvent. Let's go ahead and convert this 44.6 grams of NaCl to moles of NaCl. So we have 44.6 grams of NaCl times, for every 1 mole of NaCl, we have in the periodic table, adding sodium and chloride, about 58.40 grams. 58.40 grams. Grams of NaCl cancels out with the grams of NaCl. So 44.6 divided by 58.40. .764 moles of NaCl. Okay, so hopefully someone's double checking all of this. Molecular weight of sodium plus the molecular weight of chlorine from the periodic table. Yeah, molecular weights. Right? Like the periodic table, look the number under sodium, add it to the number under chlorine. So 0.764 moles. All right, I think we are going to solve this problem now. So once again, just to remind ourselves, okay, I want to hammer this home. Molality, small m, is mole of solute over kilogram of solvent. Okay, we got our mole of solute, which is sodium chloride here. So that's 0.764. Which is mole of NaCl. Kilogram of solvent. We have that here. .0554 kilograms. And let's do this. 0.764 divided by 0.0554. 13.8 small m molality. Small m molal. Got 5 minutes on the clock with you guys, so let's finish this one and then we will continue on Friday. All right. Again, these are tricky problems. I'll be the first to tell you. So, watch the videos, do some practice problems. I think Clutch Prep may help you with this. All right. So whatever we finish, we'll resume on Friday. An aqueous solution of sulfuric acid with a molal, small m, concentration of 8.010 molal has a density of this, 1.354 grams per mil. The density of water can be measured to be at about 1 gram per mil. What is the molar concentration of the solution? Okay, so they want big M. All right, let's identify our solute and solvent. Right, our solvent, we're going to say it's water. Okay, our solute is H2SO4. 0.010 small m of H2SO4 is the same thing as 8.010 moles of H2SO4 divided by kilogram of H2O. Is it not so that 1 kilogram of H2O is the same thing as 1,000 grams of H2O? Okay, so that is that. Let's convert this 8.010 moles H2SO4 to grams of H2SO4. Solute. Here we have 8.010 mole of H2SO4 times, for every 1 mole of H2SO4. Adding those numbers in the periodic table, I'm getting 98.03 grams of H2SO4. Right, so the moles and moles of H2SO4 cancel. Okay, I'm getting 785.2 grams of H2SO4, which is my solvent. All right, the last minute or so, let's see how far we can get here. We got our grams of solute. We'll just complete this last step here, and then we will resume on Friday. All right, so grams of solute plus grams of solution. Grams of solute plus grams of solvent equals grams of solution. I am not doing so good today, right? All right, so forgive me. Grams of solute is 785.2 grams. Grams of solvent is 1,000 grams. And this should be 1785.2 grams of solution. All right, I think this is a good stopping point. Anyways, for those of you that want to get ahead here, we have the grams of solution. We can get it to mils of solution with the density from mils of solution converted to liters. And now we have moles over liters. That will be big M. Okay. See if you can do that at home. If not, we will put the ribbon on this one on Friday, and then we will also move on to the next part of Chapter 12. So thank you, everyone. See you Friday, and please come to lab if you have the opportunity to do so. All right. See you Friday.